Okay, in this video, I'm going to show you how the simulator works on the simulation on the hardware. So this is very important because you're going to use it most of the simulations in your PBR project, since we are going to have a face-to-face meeting, and you have to understand how to use a simulator. Okay, like this. So you go back to your, remember that on the memory, right? On your memory map. So how it works is like this. This is your memory. Okay, this is a $$000 000 and this is $FFF FFF. Okay. How the simulator works, right? So let's say, for example, that you have a switch or LED. You have LED. Okay. Remember that each of your memory location, the size is 8-bit. So you can simulate, like for example this one, each of the bits here is connected to this one. So you have 8 LEDs like that. So what you need is, you need to know what is this address. What is this address? Because when you send a data to this address, and your LED will turn on or off accordingly based on the bit size, bit value, whether it's 1 or 0. You have to imagine that 1 is like a 5 volts, something that 0 is 0 volt, then your LED will be turned on and turn off, or turn off. So you're in your simulator, where is the hardware? So you can just try to write anything first. Move.byte hash F0 to D1. So this is data register, right? So you just run over here, and then where is the hardware? So you go to here, view, go to hardware. So this is your simulator. So you can see in this simulator, each of the component, each of the set is given by the address, which means that this is mapped to this one, this is mapped to this one, this is mapped to this one. So 8 of them, because each of the memory location has 8-bit. So this is also a button. I think this is a button. This is also a button. This is LED. This is 7-segment display. So it is mapped to this location, which means that you can send, you can just go to the location here. So go to the memory, go to E00010. This is the locations. Okay, this is the location where this is the location where the LED is mapped. Okay, this is where the LED is mapped. Okay, so let's try to have this area to be put something. So you are moving .byte this F0 to the location $. This is the memory location, right? To the $. So run this one, and then look at the results. At this location, you already have it mapped to the location. So let's run this one. You can see that F means 1111, 0 means 0000. So the first 4 is turned on because the value of F 1111, and the second one is 0000. Okay, so that is the case of turning on the LED at the locations of E00010. Okay, what else that you can use? The switch. How to check the switch, something like that. This is just to put the value. So I'm going to show you a very quick example on the LED. So this is the one that we have the jump subroutine, we have the delay. This is putting up the delay over here. So if you can count, because I have not teach you guys how to calculate each of the execution cycle, how much the time needed. Okay, so the BNE I've been teaching you guys in the program control branch is over there, and the return subroutine is over here. So I just want to run this one. Just run the whole thing, and then we are going to look at the hardware, right? So you can run. It does not move anything. Okay, let me try this one. There, now it's moved. This is quite long, 384614. So I'm going to reduce down this one. I'm going to reduce down to the number, okay, to this one only. Now you can see that it's blinking. Because of this program is going to be a loop here, and then make a move, make a delay over here, and then go here, and then shift this one to this one. You can see that it's actually shifting 0F to F0. So let's try to look at how it works by single line one by one. So I'm going to change this one to 1 to make it shorter the time. Okay, let's look at the command one by one. This is going to be the first one. Turning on this one, jump to subroutine, do this one, minus that one. If there's a Z is equal to 0, then you go to that one, but now Z is equal to 1, so it's going down. Return to subroutine, which is the last one before it jumps is over here. So move to this one and then execute this one. You can see this is the one, and then you go to the same delay again, and then you will go to branch loop over there, and then switch again. So you can see that if I change the value, okay, the LED is going to be turned on and off repeatedly, okay, based on the value that you put over here. So this is mapped to this location. Okay, this is mapped to this location. So when you put this value to this map array location, so it will behave like this to this. Okay, another example for the simulator, I'm going to show you how you want to use the switch. So where's the switch over here? I just want to show you guys where is the switches map first. So I just want to put something here so I can just get the hardware to be viewed. $sign to the 0. Then I run this one. I just want to know where is the hardware for the switch. So the switch is at this address, is at E000112. Okay, so this is mapped to this one. So what I'm going to do is I want to use this switch to turn on the LED. So you just imagine that by using a switch, you are going to turn on the lights. So I'm going to use this one to turn on the whole light over here. So let's try. Okay. Here, I just want to try, I'm going to move the contents, move dot byte hash $00 to the LED. This one I want to turn off the LED, so it's going to be a $, E, the map and the hardware is this one 00010. Okay, this is the command to turn off the LED. So then I want to check the switch, because based on the switch I'm going to make a decision whether it's going to be turned on or turned off. Let's say for example, if I see the switch is equivalent to 1, means that it's on, then I'm going to turn on the lights. So the command will be this one, move dot byte the map area for the switch is $E000112. Okay, this is the place where the switch is mapped. So I'm going to move this value to any data any data register. So I'm going to put it at D0. Okay, then I'm going to test one of the bit in this D0. So we can use bit test. Okay. Bit number 0 at D0. Right? So you're going to test one of the bit. Remember that I just want to show you how. Okay, so just imagine that this is your memory again. This is your memory at E000112. This is mapped to the switch. So just now you have 1, 2, 3, 4, 5, 6, 7, 8. Should be 8. And then just now from the hardware you can see that there are 8 switches here. 1, 2, 3, 4. So each switch is for the bit over here, each of them. Same goes to the LED. So what I'm going to check is if the bit is here is 1, then this is going to be turned on the whole light at the LED. Okay, so I'm going to check only this bit, the rest I don't really care. Okay, so from here I can test the bit 0, D0. Then from this one I'm going to make a decision based on the Z flag. So Z flag we only have 2. One they call it B is B and E, branch not equal. Another one is branch equal. So this one will branch if your Z still equivalent to 0, and this one will branch if your Z is equivalent to 1. So I'm going to use this one to check whether the contents bit 0 is 0, means that when I test this one, then I'm going to have Z is equivalent to 1 if the value is 0. So right now if I want to check that one, okay, so if Z is equivalent to 1 means that the operation for the bit test is equivalent to 0. So I'm checking this one. If there's 0, then my Z is equal to 1. So it should be BEQ. Okay, so 0 means off. So right now I'm going to make these decisions BEQ. I have to branch to this line again. So I have to move to this one. So I'm going to label this one. This one should be off. Alright. So let's make it. So this is branch to off. Okay, is there any problem yet? So there's no problem. So okay, we can run this one. Just want to see this one first. You can run fully this one. This is always run, right? This is always run. So you go to your hardware, try to play this one. There's nothing happen, right? It's not on off because the code that you write is still with 00. So we can close this one. So now the thing is doing this one all the while. So let's check again whether it's correct or not. Yeah. So what happened? Okay, what happened if now the bit test at bit 0 is equivalent to 1? So if the bit 0 is equivalent to 1, then your Z flag will be 0, right? So you will not branch to the off. So what you can do here, is So means that right now your bit test for the bit number 0, okay, when your bit number 0 is 1, you test the bit, means you're going to get the Z is equivalent to 0. If this one, then it's not going to branch, it will go down. So right now what you can do is you can make the program to on it. So this is going to be move dot byte hash $ FF to this location again, because this is the same location where you want to put your LED. And then you're going to test again, because you have to keep testing the switch condition, this one again. And let's say that you have to test again, because you need to know that the condition is what at the moment, right? Because it needs to know whether it's on and off here. And then here you are going to use, instead of BEQ, you're going to use BNE, because BNE means if the Z is equivalent to 0, then you are going to look at on condition here. Okay, then if the bit test for the bit number 0 is equivalent to 0, then it will go down. Means that you can write a syntax over here, branch to off again. Okay, this is the one. So let's try. There's no problem here. Let's try to this one, because we need to play with the hardware over here. Okay, let's run this one. Now the LED is off, right? So what happened here is always like this. So let's try. I'm going to turn on the first switch over here. So let's run this one. Then it's go down because the checking happened over here. Now it's only moved to this one, right? So I change this one again. This is going to be tested over here. Then it should do what? After this test, it's not going to be inside the same loop again, because it's going to go down and then we'll go to branch off. So you have to imagine that this is a fast process. When you see this one, this is like you do not run it one by one. So I can see that you can use as a switch over here. Alright, you can try by yourself here. And I'm going to give you another one which is normally being used for the delay. Okay, let's try to look at the delay. So you can try to write on this one also. Okay, I'm going to take it out this one. You just can play around one by one. This is like your traffic light program, because this is the one that creating the delay. So when you change the value over here, the delay will be changing. How long the delay will be based on how many counts it needs. So you have to view the hardware on this one. So this is very fast, right? So it's okay. Now I'm going to make it higher. So close this one. Right, now we are going to run this one. Look at the hardware. So you can see that this is moving one by one. So this one is using the jump to subroutine, and then this is subroutine, return to subroutine must together with the jump to subroutine. So you can see that this is how I'm doing it for the process of the, for example, this is just like a traffic light. Okay, that's all for the example that I can give to you guys. I hope that you guys can try it and apply it later for the projects for the microprocessor. So thank you very much.